In this video, we will write a Kotlin program to convert binary number to decimal and vice versa. Okay, convert binary to decimal and vice. Okay, so if you don't know, binary is the language that we talk to computers about, and decimal is the number system we generally use. Okay, so the binaries is the number system of zeros and ones. Okay, so in this program you will learn to convert binary number to a decimal number. So firstly, we will write a program to convert binary to decimal. Now let me create a main function. Now what we have to do when we have to convert a binary number to decimal number. So binary number, let's say there is 1 1. So the 1 at the least significant bit has the power 2 to the power 0, and at the most significant bit has 2 to the power 1. So it is 2 to the power 1 into 1 plus 2 to the power 0 into 1, and it is equals to 3. Okay, so let's say I have a binary number. I'll declare a binary number num, and I'll declare its data type as long, because it could be as long as 110110111. Okay, now I'll declare a decimal number. So I'll declare a value decimal, and what I'll do is, before this, I'll instead of doing all the calculations here outside the main function, I'll make a function which to convert a binary to decimal. Okay, now this function has to take something as an input. Okay, so let's say it takes input num, and its data type is long. Okay, now after that we have to declare its output is int. Okay, output type. Now we start the code block. Okay, now inside the code block we have to convert the binary to the decimal. Okay, now so we have to use loop. Okay, and like we have to okay, so the decimal base 10 and number system has possible value 0 to 9 for each place value. Okay, in contrast, the binary base 2 number system has two possible values, 0 and 1. Okay, so how to for converting this converting decimal to binary is like I have okay, I have to show like this. Okay, I have 110110111. Okay, so the least significant bit here is this. The most significant bit here is the first one, and this is the least significant bit. So the least significant bit holds 2 to the power 0. 2 to the power 0 is 1. Okay, and then the next bit holds the value 2. Okay, and again the next bit holds the value 4. Okay, and so on. It holds the value 8. Now it holds the value 16. Okay, and this bit holds the value 32. This bit holds the value 64. So for converting this into the decimal, I have to multiply these two. So I have to multiply 1 into 1, and then multiply 2 into 1, and then multiply 4 into 1, and then multiply 8 into 0, and then multiply 16 into 1, and then add the whole thing. Okay, so I guess this is pretty clear how to convert a decimal number to binary. Okay, so now we will move forward to how to write the code. Okay, so firstly I'll declare the variable num, which is equals to the num input that we have introduced. Okay, Now I'll declare a decimal number which will be our output, decimal number, and for starting we will declare it as 0 because we have to add all the numbers. Okay, I have introduced early that when we have to add all those numbers we will initialize it as 0, and when we have to multiply all some numbers we will initialize it as 1. Okay, now I'll introduce an iterator, and that would be 0 for starting. Now I'll introduce a variable remainder, and uh, its data type as long. Okay, okay, just a second. So continuing with the problem for converting binary. Okay, so it is clear that how we can convert binary to decimal. Okay, so after declaring the remainder, I will run a loop. Okay, so running okay, a while loop. So while now the number is binary. Okay, so okay, so number is long. Okay, so I'll convert the long to int, and then I'll num to int, and then when it is not equal to 0, till then I have to run this loop. Now inside this loop, so I'll divide the binary number by 10. Okay, so what will happen is no, yeah, and the remainder that will be so when I divide this number by 10, the remainder is the last digit. Okay, so I'll collect the last digit by dividing this number. Okay, so the remainder is equals to the remainder when the number is divided to 10. Okay, so now we have the last digit, and for continuation I'll divide the num and provide it to the. Okay, so as we did in the previous video we will do, and the decimal number would now be equal to the old decimal number. So I'll give it plus equals to, and it will be equal to old decimal number plus remainder into math.pow. I'll have to do the power, and power of 2 is the base 2.0, and the iterator. What is happening? Okay, and the iterator that is I, and I'll convert it to double. And then I have to convert this whole to int because the decimal number is an integer. So to int. Now I have to increase the iterator, and then at the end of this loop I have to return the decimal number. Okay, so what we did in this part of code is while the binary number is not equal to 0 because we are dividing the binary number by 10 in every iteration. Okay, so while this is not equal to 0, the remainder is calculated, and the remainder into 2 to the power 0 to the power 1 to the power 2 is then calculated and then multiplied to the remainder. and then add it to the decimal number. Okay, so as I have explained this how to the conversion of this, and then I have to call this function. Okay, so calling this function, I'll introduce a value decimal that would be equals to convert binary to decimal, and then the input would be num. Okay, what happened here is uh, okay, now it would be correct, yeah. Okay, and then I'll print that number in binary is equals to decimal in decimal. Okay, so when I go ahead and run this program, I can see the output. Okay, the grid is building. So I can see here the output is 110110111 in binary is 439 in decimal. Okay, so you can also check that this is correct. Now instead of doing this whole thing, there is a integer to binary string method to convert a decimal number into binary. Okay, so what we can do is inside the main function for converting decimal to binary. Okay, for binary to decimal, this is only the way. Okay, so if I have to convert a decimal to binary, I'll create a main function, and then inside the main function there would be a number, let's say 19, and then I'll converting decimal to binary. Now value binary is equals to integer dot to binary string, and then I'll place here num. Okay, now if I print that num in decimal is equals to binary in binary. Okay, so when I run this program, I can see that 19 in decimal is 10011 in binary. Okay, so that is all for this video. Stay tuned.